The Thwaites Glacier is one of the largest in Antarctica, and it is melting at an alarming rate. The world took notice earlier this month when temperatures there hit nearly 70 degrees. But getting a better read on what's happening has been a challenge. Our science correspondent Miles O'Brien gave scientist David Holland and his team camera equipment to document their mission to the glacier. Miles has this dispatch as part of our series, The Leading Edge.
It's an urgent scientific mission at the far edge of what's possible, to the edge of a massive melting glacier. It's the largest, most menacing source of rising sea levels all over the world. Welcome to the Thwaites Glacier in West Antarctica. Our guide on this journey is David Holland, a professor of math and atmosphere ocean science at New York University. He is a principal investigator on the MELT project, part of the International Thwaites Glacier Collaboration. The 5-year campaign is funded by the UK Natural Environment Research Council and the US National Science Foundation, a NewsHour funder as well. Why is Thwaites so important? Why is it worth the effort?
So it's the most vulnerable place on Earth, and the curious thing is, how is it that it's so vulnerable and at the same time it has warm water in front of it today? These are just two things that may be coincidental, but they're both real. And they're happening.
For years, scientists have warily watched Thwaites from afar using NASA satellites. About the size of Florida, it is vanishing at an alarming rate, retreating about a half mile and thinning as much as 15 feet every year. It sits on land below sea level. There is nothing to stop its accelerating retreat. It could melt away in a few decades. Some call it the Doomsday Glacier.
If Thwaites were to melt or drop into the sea tomorrow, how much sea level rise would we expect?
So it's less than a meter. It's probably of order of, say, 65 centimeters. Then the neighboring ice would become unstable. And so altogether, it'd be more than 3 meters of ice, something of scale 10 feet. It's a major change, a rewriting of the coastline.
Thwaites is like a cork in a bottle. Once it is gone, there will be nothing to stop a cascading loss of nearly all the glaciers in West Antarctica. That is why Holland wanted to come to this place, to drill a half-mile hole through the ice to see what's happening underneath. It's never been done before, and it very nearly did not happen this Antarctic summer.
The motto for me is, have no expectations. If you have expectations, you will be deeply disappointed.
In November, they flew to Christchurch, New Zealand. Within a few days, they were on a U.S. Air Force Air Mobility Command C-17, stuffed to the gills with scientists, support crews, and gear. After a 5-hour-long flight due south 2,300 miles, they landed at McMurdo Station, headquarters for the National Science Foundation in Antarctica. But they were still more than 1,300 difficult miles away from their camp on Thwaites, and the weather was terrible, and the airplanes kept breaking down. What was to be a 1-week stop in McMurdo for briefings, training, and practice became more than a month. By the time they got to Thwaites, all the weather and mechanical trouble left them barely enough time to do their science. But safety first.
We're out at the grounding zone for Thwaites Glacier right now.
A team led by geophysicist Seth Campbell of the University of Maine surveyed the area. He explored some nearby caves.
Things have never been seen, probably.
And towed a ground-penetrating radar on a sled to identify perilous crevasses beneath the surface.
If you zoom in here, we can show you what they look like. The way radar works is we're imaging layers in the snowpack below us. So we can see there's a crevasse here, and we can see there's actually a crevasse here as well.
Others were more obvious. Working on the edge of a glacier is dangerous business. A wrong step would be fatal.
Well, I think we'll go around this one.
They also looked beneath the ice using another technique called seismic reflection, ironically often used by the oil industry to find places to drill. But in this case, they're making an underground map to ensure they are where the ice transitions from sitting on the rock to floating in the ocean, the so-called grounding line. They detonated some small buried explosives akin to fireworks. Lizzie Klein is a doctoral candidate at Penn State.
When we set off that explosive charge, that creates a bunch of seismic energy that radiates down through the ice to the bed, to the bottom of your shelf. Any sort of change in material will trigger a reflection that comes back to us. And so this way we can see whether there's water or there's sediment or there's rock beneath the ice.
The reflections they recorded showed the ice, the seafloor, and a thin column of water. A bullseye, exactly where the team wanted to drill. They don't use drill bits here, just hot water, nearly boiling. The rig requires several aviation fuel-powered burners attached to a long spool of hose.
We see the drill rig, and then the hose goes down through a hole in the ground here, right there.
Is it risky ultimately to the glacier itself?
No, because it's such a small fraction of the glacier. We're like literally touching 1/1,000,000% of the glacier.
When they finally got started drilling, a big storm blew in.
Well, you really cannot see nothing visible at all. Just stay in here for the day.
The team had to hunker down for 3 days. The timing was not looking good.
If we don't get the drilling started tomorrow, then we run into a whole series of problems. Basically, there's another storm coming in about 3 days, but we need 3 days to get the drilling set up and done.
But when the storm passed, the good weather held, and things fell into place quickly. After 36 hours of hot water drilling, they broke through the bottom of the ice to the ocean a half-mile beneath. They lowered in a remotely operated vehicle called IceFin, which provided some unprecedented images of the ice-covered shore of a glacier. Funded by NASA, the device was built by a team from Georgia Tech, led by astrobiologist Brittany Schmidt.
One of the things that we don't know very well is exactly how glaciers move and how the very base of the glacier operates. So when we get to see it right up close, right where it starts to hit the ocean, we're seeing the freshest material.
They collected sediment cores and dropped in instruments that measure water salinity, temperature, and turbulence. It turns out the water at this particular spot is very still. Aurora Bazinski is a grad student at NYU.
Since turbulence is below detectable levels, that means that there isn't as much mixing as potentially we would have expected. And so what that means is that the warm water is mostly staying near the bottom and not necessarily making its way up to the ice.
That might seem like good news, but for the first time, scientists have confirmed what they suspected. The ocean under Thwaites is warm, 3.6 degrees Fahrenheit above freezing, too warm for the ice to remain stable.
It's a sobering moment too, isn't it?
Yeah. Change happens, and this looks like a potential case for change going forward that could be quite impactful. You can probably change air temperature over the next century, but the ocean is such a big, sluggish creature that in a way, when it's doing what it's doing, it's not the kind of thing we can engineer and stop very easily.
Before they left, the team buried 5 GPS stations across the grounding line. They will gather precise data about the glacier's movement and thickness over the long, dark winter. The MELT team plans to be back next year to recover that data and do more science. They hope this risky work at the edge of possible will help researchers make better forecast models, adding more facts to the growing fear. For the PBS NewsHour, I'm Miles O'Brien.